bad news. Bad fucking bad news. We don't have the screen another time because USB port is fucked up. I can charge the phone, but I cannot connect it through these cables from here to here. Do you remember? They're always on the way. But nothing stops us. Nothing is gonna stop us. We will do it. And after this, I will gonna go fix it. Yeah. So what do we have to do? Product specific. So we had an issue that we had an issue. Twitter solved it. That on eBay the products come and go. Like there's a product come, like there is only one item. It's not like there is this store on Amazon that keeps providing the same like water bottle or tablet case. It's just there's one guy who decides to sell. It's like Facebook Marketplace. So they don't have much information about the guy. Historic information is low. They don't know much about the product. They only have description of the products. So that's the only information we can sort based on. That's one thing. And then we said, all right, even in Twitter is the same. Well, it's not exactly the same because people, I think they can give a score to the people, but or like people who tweet, they used to, because every new tweet, should they put it on the top or low, they don't know how amazing that tweet is, right? They know that the guy is important, or that's the only information they have. So Twitter is a bit good because every tweet is a new tweet, and they don't know the quality of that tweet. But in Amazon, they know the quality of that product based on previous customer engagement. So in that sense, we can still say, all right, we can use still ranking algorithms in some senses. And that fast changing eBay constraint may not be as important. That's one thing. I want to clear that up. Or maybe no, keep it for one more session. I cannot pause it now. Fuck this! Then we have product specific latent features. So we have like product descriptions, and we have product descriptions. Based on those, we are gonna sort the items. However, which item should we put first matters. So we are gonna sort based on product description. That's one thing. And not really. The seller may, okay, I don't know how like often the sellers are there. So we still can sort based on some features. That's always the case. And now Ursu, which is the paper on Expedia, once Negin told me we can take a look at them, and also Weitzman model, multi-type estimation. And then we also mentioned maybe it is just eBay is not great, their algorithm is not amazing. Who knows? Maybe is there a novelty in the study that we wanna do? Is it like a research project, or is it just an engineering project to fix some issues? I want to also listen to some of the voices, voice memos, but I cannot share it with you because they are very exclusive, very, very exclusive. Perfect. So okay, that's it. We are gonna go. What does featureize mean, by the way? Featureize mean. What does featureizing mean in machine learning or anything?
Great question.
Her voice changed.
Featureizing simply means converting raw data into a structured set of features that a machine learning model can understand and learn from. Why do we featureize? Most ML models don't work directly with raw stuff like text, images, or raw logs. They need numerical input, usually in the form of a vector, like a list of numbers. Featurizing bridges that gap. Examples. Text data featurizing a review like, "This hotel was excellent," might turn into, "Bag of words counts excellent," etc. How unique each word is. Embeddings, like a 300-dimensional vector from Word2Vec or BERT. Images featurizing an image might involve pixel intensities, raw pixels. Pre-trained CNN embeddings from a model like ResNet. User behavior logs. If you have logs of clicks or purchases, you might featurize time of day, product category, device type, number of previous visits. Featurizing versus feature engineering. Featurizing is often automatic, e.g., converting text into vectors. Feature engineering is usually more manual and creative, combining or transforming features based on domain knowledge. In summary, featurizing equals turning messy, raw images.
Alright guys, I think I cannot pause. If I pause it, it will turn it up, so. Honestly, I didn't use the keyboard in the kitchen. I don't know where the oil is coming from. It's olive oil. La 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 la. So let's go. We looked at that paper before. What we want to do is seeing if we can add this multiple tell me multiple categories inside it. So I have my ChatGPT ready here. You want to also add the overleaf and ranking algorithms, no. TA application, no. Okay, ranking algorithms. Yeah, can you just close that shit? Beautiful. Okay, ranking algorithms, and we want to go related literature, and we want to also let's go open over. Okay, overleaf. Okay, yes. And whole set ranking. We want to add this related literature section. References, Yamaha, literature. I just want to add them once in a while, and oh shit, I need to add. Alright, this is just part of the game, guys. چون تو شبای من نمیده رفت. Where is it? Papers. Papers. Expedia. Raluca M. Ursu. What is this? Yeah, just writing down this stuff. Expedia. And I wanna mention Alright, like the paper, The Power of Ranking, Quantifying the Effect of Ranking on Online Customer Search and Purchase Decision by Raluca represents a rigorous empirical and structural analysis of how ranking on platforms like Expedia affect consumer behavior. Just let me add just one Ursu here. So Ursu, and we want to see which part of it is related to what I want to do. Like this is a paper about ranking. It's not about categorization in ranking, and my note is about how we can Categorization or kind. Come on. What are the ideas? Fuck. Okay. Presents a rigorous empirical and structural analysis of how ranking on platforms like Expedia affect consumer behavior. What is the paper about? In plain terms, it studies how the position of products in a rank list, like a hotel on Expedia, influences. Okay, the thing is with Expedia or Airbnb is that, yeah, the spots go once they are sold, and you cannot rent them or buy them for the same time anymore, but they come back. So customers feedback, like Amazon, the product always there, like it's a constant stream of selling the product because they have huge inventory, and the seller, and so they don't go out of stock. Sometimes they go, but most of the time we can assume they don't go out of stock. We have feedback on the same item on Airbnb, Expedia. Once they are sold, they are not available for a while for that time stop. However, they will come back. It's not constant stream, but it is a stream that gets like occupied once in a while and has pauses. It goes out of stock. It's another extreme, but um, similarity is that we still have feedback on the same item or product. On eBay, the stream is not constant. They just show up and disappear forever most of the time, and um, they show up and disappear most of the time. And the other one is that we don't have feedback on the same product. We don't have feedback on it. So feedback does not exist kind of in eBay. Let me add this. Right. In a sense, right? For similar items, feedback exists. Feedback. Lack of historical data, I like to say. Data. And lack of historical data and feedback. Now I want to know. So eBay says, well, the product sold on my platform is mostly like things that are unique. It's not a commodity market. It's a place you find great deals with uh, or unique products. Great deals probably means lower price. And I want to know great deals and unique items. How much of eBay is this? Is it called the slogan? eBay's revenue. How much age they have? Okay. Now, okay, these are general, big picture. Not okay. These are the facts. These are the reality we have to deal with on the theoretical side and thinking side. Dude, I'm worried I have to go to restroom. What is the paper about in plain terms? Studies how the position of a product in a rank list, like a hotel expert, influences whether people click on it and eventually buy it. Crucially, it answers, do people click more on top rank? Okay, I think the Expedia paper shows that it depends on ranking, however, it does not depend heavily on ranking, meaning that ranking really helps you getting the clicks, but final purchase or renting the hotel, like they create that consideration sets, like in Nagin's paper, and once like multiple items are in a consideration set, then people do not care about the ranking much. Ranking really helps on getting the clicks. The rest, people go put more time and try to make decision with more patience or intelligence. It crucially attends that do people click more on top rank this item just because they are top rank? Does being at the top actually lead to more purchases? To answer these, Arthur uses a randomized field experiment on Expedia where hotel ranking. Well, there is one standard Expedia ranking based on the relevance algorithm, and the other one is randomized ranking, completely random. And key model, sequential search model. Oh, okay. Ah, okay. Because the other um, thing on my list was this Weitzman. Weitzman 1979, by the way. The model is built in 1979. I want to know what was he doing in 1979? What kind of digital platform did we have? Let's ask ChatGPT. The Weitzman model in 1979, the sequential search model. What was the application of that model at that time? We didn't have any digital platforms.
Exactly. And that's a really sharp observation.
Fucking
When
hate her
Weitzman introduced
voice.
the sequential search model in 1979, it wasn't meant for digital platforms. Those didn't exist yet. Instead, he was thinking about economic decisions involving costly information gathering in a very general sense. Original context of the Weitzman model, 1979. The paper was titled Optimal Search for the Best Alternative, and the main question was, if you're looking for the best option among many, and it's costly to examine each one, how should you search? Applications he had in mind included job search. A person can apply to jobs one at a time, learn about them, wage location, and decide whether to accept or keep looking. Marriage mate selection. Meeting potential partners
So
sequentially
it is
and
like
deciding when to stop. House hunting. Visiting
optimal
houses and
stopping
deciding
rule.
whether to buy or continue searching. Industrial inspection, checking parts or components one by one until a good one is found. So the focus was on search under uncertainty with cost, and it was very theoretical but flexible, laying the groundwork for modern search theory. Key insight. Even without digital platforms, search behavior was everywhere, just slower and more manual. What's cool is that this model turned out to be perfectly suited for digital consumer behavior decades later, like browsing products on Amazon, clicking hotels on Expedia, swiping on Tinder. So while Weitzman didn't have the internet in mind, his model ended up being a foundational tool for understanding how we explore options, online or offline. Want to dive into how it actually works or
So okay, that's crazy. So what is it called? Rebirth, maybe. Weisman model, Weitzman or Weitzman? Okay. Key model, sequential search model, Weitzman. Okay, that's the key model. Each hotel J has two components of utility for a consumer: VJ, observable info, stars, reviews, price, etc. So these are observable. And epsilon J is the random component revealed after clicking. Photos, amenity, like it is the before versus after comparison, right? Epsilon j is versus after. Um, so so we have the observable Vj, and epsilon j is the random component. So this is nice. How can it be compared to our model? Is that our model, we just have relevances, which we want to learn actually. We don't want to. In our model, we don't assume we know these VJs. We want to learn them. Well, the thing is that in multinomial logit or logit models, logit, I don't know. The way they don't say we are gonna maximize the utility, they say the probability of an item being selected is proportional to this utility, and it is like e to the vj over sum over e to the vj plus 1. But consumers only get vj for free. This is also true in Negin's paper, where they had this consideration said the epsilon j part should be realized once they put it in the considerations. All right, I am repeating myself too much. Unnecessary. They must pay a search cost CJ. So for costs, for finding epsilon j, they need to pay a cost CJ, which increases with position. So the further you go, it costs you more. However, the main difference between this and optimal stopping rule is that in the optimal stopping rule, we assume no search cost. Therefore, you say, all right, the first or n over e, you just explore, and then for the rest, find the one that is better than the rest. Also, in optimal stopping rule, once you see an object and you reject it, you cannot go back to it. But here you can definitely. In the there is this comparison does not exist in a sense. Okay, they are about the same thing. You are dealing with a list of items. You don't know what will happen next, but there are differences too. There is no search cost there. Here you cannot, for example, in cascade model, we do not let you go back on the list also. I mean, in reality, on Amazon, eBay, wherever, you can go back. In our models simplify reality. It's completely fine. You cannot go back. On cascade model, you cannot go back. On two-stage models, you can. Consideration sets, you can. And so here, in a sense, you can. You just choose some of them, and then epsilon. All right. So, and CJ is exponential, which is search cost, k plus lambda position j. K is constant, lambda position j. All right. So lower rank products have lower. Lower means at the bottom of the list. Cost more to explore, more scrolling or mental fatigue. Exactly. Search rules, Weitzman search algorithm. So what is your final utility? Is it minus CJ, e to the UJ? Computer reservation utility, ZJ, VJ plus sigma J, MJ. Oh, it is that's actually the algorithm, the solution Weitzman is offering. Computer reservation utility, we have VJ, we don't know epsilon J. Instead, you compute ZJ, which is VJ plus sigma J. Well, we know, we don't know what the realization of the noise is, but we know its characteristics. So VJ plus sigma J, MJ. What is MJ? Where MJ solves an integral depending on CJ, which is cost. Click Search item is decreasing order of ZJ. Click items. So you create these ZJs, which we have VJ, we have Sigma J, MJ, we are gonna create it. We sort based on ZJ, and you choose the one. Stop searching when your best observed UJ. Well, we don't have UJ observed. Exceeds all remaining ZJ. Okay. That's very clear. Okay, so we rank based on ZJ items. We look at the UJ because we are gonna pay for the cost of search cost of items that are sorted, and then we pay all of those search costs, and then we stop. This part is kind of unrealistic, right? You cannot you cannot compute these MJs because, first of all, computing fucking MJ costs you too. Okay, that I'm being too picky, but too rigorous, too strict on them. All right, let's assume they can compute MJs. Then you sort based on them, and once UJ is bigger than all the remaining ZJs, is this a realistic approach? I don't think so. So once your UJ is above all of the remaining ZJs, you stop. Okay, this is, by the way, his algorithm. It's not the optimal or by the item with highest UJ. So how can we evaluate this model? Like how good this algorithm works? What did the author find? Ranking affects click but not purchase. I talked about it. No difference in conversion rates once someone clicks. Ranking only helps getting attention, not close the deal. You still need to have once your epsilon j is observed. Most prior studies overestimated the effect of ranking. So overestimate. They were like, all I was talking about. So, okay, this is also getting click is also important. You cannot go all the way down. So I think ranking matters. Getting click also matters. This is also about what Ehsan was talking about, multi-touch attribute. How much of a purchase depends on getting the click. If you are not getting the click, you are not being purchased. Most prior studies overestimated the effect of ranking. However, you can still overestimate. Using random ranking, she finds Ursu is the name of her lady. She finds an average position effect of $1.92 in search cost. What does that mean? Lower than prior estimate, $7 to $35. Those estimates were so high. So that's beautiful. That is really an impact my research can have. Like, yeah, we can always talk intuitively and say, okay, this part, of course, if you're at the top of the ranking, you have more value. These are all intuitive talks, but how much is those position? How much is the value of each of those positions? That we cannot be intuitive because, like, sellers are paying sponsorship to be seen at the top. They don't want to pay a lot of money if they are based on a wrong, overestimated effect. They are gonna pay a lot. But if our study can give better understanding the value of the ranking in terms of numbers, exact numbers, people have better understanding of how much this ranking matters. So that can be very high impactful part of the study, like making it to numbers. Her study is also like she had the opportunity to run experiments on Expedia, and this is amazing. And then she could, through experimental study, she could say, okay, this is actually 1.92 search cost, and that's beautiful. Okay, I hope we can do something similar. The main effect of ranking is reducing search cost. Exactly, you want to reduce the search cost. And consumers stop earlier when good options are near the top. Like in optimal stopping rule problem, there is no effect of ranking. They're just there. While a platform has the power to help their users to find what they, that's what the platform you should do most of the time, right? First step for platform is helping their users finding what they want. Then you can say, all right, once you are good at this, you can focus on increasing your revenue. But that is the meat of what a platform should do, bringing the relevant item to the top. The main effect of ranking is reducing search costs. 35% of welfare gain comes from reduced search costs. So, if it is randomly, if it is not randomly, platform 35% welfare gain. That's huge. A utility-based ranking improves outcome. Hotels by predicted customers improves consumer surplus by $30. They don't buy shitty stuff and per purchase. So platforms really helpful. This fucking algorithm is not devil. It is an angel. $30 helps platform transactions by $2.4. Okay, I don't know this $30. What basket of product was? What was the average price of product they were looking? A hotel, was it like $100 a night or was it like $1,000 a night? Platform transactions by 2.4%. And then if you are providing better consumer value to consumer, you can take part of it for you as the platform too. That's the whole idea. Summary of mathematical model. Consumer utility UIJ is Xij beta plus epsilon. So wait a second, what happened to that U? What is I? Search cost Cij. Why do we have Ij suddenly? And reservation value Zj Vj. Mj is B minus B inverse of Cj over sigma j. But we don't have Cj's. Oh, we do have. So they assume CJs. They do not learn them. All right. Okay. So we have Cij. What is the difference of Cij and Cj? Search and choice rules follow Weizmann. Search until you have best observed Uj greater than all the remaining Zj. Choose product with the higher. Final takeaways. Position affects search, not decision making. Post search. Okay. This is beautiful. The real power of ranking is in helping consumers reduce search costs, not in convincing them to buy inferior products, because they, once they choose their consideration set, they are not a stupid human. Would you like a Python simulation of the sequential search process? How to build a utility-based ranking? Okay, what is the difference? Yeah, I want to know what is Cij. Why do you use Cij? C. Let's take a look at the paper. I can't trust ChatGPT on this one. So they have Cj, which is UI, Zi, UI minus Zi, DUI. Alright. I don't see still any Cij or UI. Oh, they have UIJ. So what is this? I love it. I fucking Ursu now consider the empirical specification on of the model. Okay, this is the empirical. Let consumer I's utility from purchase hotel J. Oh, because they have, okay, I stands for the consumer. Because now they are accessing different people's data. Alright. Uij is Vij plus epsilon ij, where epsilon ij is why oh, okay, it depends on the product. Alright. So they don't talk about re-ranking. Or they do. Because if they have one study that they are saying we rank products randomly and the other based on Expedia's relevance score, you're saying this epsilon ij noise variance depends on sigma j, meaning that it only depends on the position, which doesn't make sense. So you're saying the variance of the noise that will be final. No, this cannot be true, alright? Honestly, I have to go to the restroom. Alright, great catch. Let's clear this up. Both CIJ and CJ refer to search costs, but they represent different models. So CJ is for the theoretical part, CIJ is for the empirical part where they're dealing with dataset. Search costs for product J assumed to be the same for everyone. CIJ search costs for customer I to examine product J allows for personalized or heterogeneous search costs. Oh, okay. Versus paper, the power of ranking uses CJ exp k plus lambda position J, so the search cost depends only on the rank, not the individual customer trace. As customers that's it. So technically CJ is used throughout